Welcome. The topic we'll be discussing in this lecture is subroutines. Okay. Subroutines are similar to procedures or functions in high level language. In the context of assembly languages, instead of using the term procedures or functions, we use the term subroutines. Okay. Say for example, there is a particular task which you want to perform again and again. Maybe that may be calculating uh, area of a circle, or calculating sign of a function, anything, a particular task which you want to do to repeatedly. Then what we can do in the sense, we can put those codes as a block. We can implement that task as a block of instructions. Block means a set of instructions. We can implement whatever the task we want to do, that can be implemented as a block of instructions, and this block of instructions can be called as subroutine. This block of instructions can be called as subroutine, and this block of instructions will have a name. This block of instruction will have a name which is called as the name of the subroutine. Now whenever you want to perform that operation, it is just enough to call that subroutine using that name, and the task will be done. That is, by writing subroutine, what we are doing in the sense, uh, we are we are not unnecessarily rewriting the code. Okay, rather we are using the code, uh, whether rather we are using the existing code in a better way, which can be called as code reusability. Say for example, a particular task, say calculating area of a circle, that in a program you want to do 10 times. Then 10 times you need not write the code to calculate the area of the circle. Rather, you can write one subroutine which will calculate the area of the circle, and you can call that subroutine 10 times wherever it is required. Okay. So basically that is what subroutine does. Subroutine is a block of instructions with a particular name, and it is generally these block of instructions should be called repeatedly. So whenever the programmer or the user wants to call, they will just call it. So it need not be implemented again and again. Okay. So what it does, so the main advantage is it saves space. That is, it saves the is code space and also memory space, because you are not keeping multiple copies of the code. Only one copy of this block is placed in the memory. Okay, and when somebody wants to access it again and again, they will just call that. So the call instruction, there will be a call instruction which is used to call the subroutine. So whenever the call instruction is being executed, then the control will move from the current program which is getting executed to this particular subroutine. Okay, right? And after executing the subroutine, the control should return to the calling program. The control should return to the calling program, and that will happen through the return instruction. Okay. So let us see how this can be implemented. So when we say that whenever there is a call instruction, the control should go to the subroutine. So that will be done through PC, program counter. Okay. So the call instruction may be something, but the starting address of the subroutine may be something else. So whenever there is a call instruction, the program counter will be replaced with the starting address of that particular subroutine. If the starting address of the subroutine is 5000, then the program counter will be replaced with 5000. Okay, so that control will go to 5000, and from there it will start executing, right? Similarly, whenever the return instruction is getting executed, uh, what will happen in the sense, uh, yeah, before the call itself, uh, when the call instruction is executed, program counter will store the starting address of the subroutine. Not only that, it will also do something else. In a special purpose register, in one of the registers, it will push the return address. Say the return address is 1004. So it will push that address in another register, which is a special purpose register. Okay. So now when there is a call instruction, the program counter will update it with the address of the subroutine. Okay. So the subroutine will execute. After finishing execution of the subroutine, once the subroutine ends, the last statement in the subroutine will be return statement. When the return statement is executed, uh, the whatever the thing that is available in this special register will be popped out. So what is that 1004? So that is the return address. So the control will transfer to the return address. Okay, that is it will just continue from the instruction that follows the call instruction. Okay. So this is how subroutines are getting executed through call and return instruction. Fine. Okay. So as I have already said, during call instruction, the PC must be saved by the call instruction to enable correct return to the calling program. Okay. That is originally PC will be having something, right? If the call instruction is this, okay, and then the instruction that follows call instruction will be something else. Okay. So if there is no call instruction, say call some subroutine, if there is no call instruction, then which instruction will execute? Obviously the one that follows that instruction will execute. Okay, so it means that control should return here. Okay, so that will be the return address will be pushed into a register. That register is called as link register. The return instruction, the address of the return instruction will be pushed into a register. That register is called as link register. Okay. Okay, so there will be something called as link register, and in this link register the return address will be pushed, and okay, and call will be updated with the starting address of the subroutine. Call will be updated with the starting address of the subroutine. Okay, now what happens? The control will go to the subroutine, it will execute the subroutine. The last statement in the subroutine will be the return statement. When the return statement is executed, then automatically the content of the link register will be popped out, and the control will go back to the statement that follows the call instruction. Fine. So here saving the PC means saving the uh, next address of the PC. Okay, current address is call instruction, but when the current instruction is getting executed, the next instruction will be updated in the PC. Okay, but now the control is not going to execute the next instruction. Rather, it is going to the control is going to shift to the subroutine call. Okay, but still after finishing the subroutine, we have to come back here. So this next instruction should be saved. Okay, the address of the next instruction should be saved, and that is saved in which register? In link register. That is the point. Okay, and whenever there is a subroutine call, the PC will be updated with the starting address of the subroutine. So what happens? Subroutine will execute, and when the return statement is executed, automatically the assembler will check what is there in the link register, and the link register content will be popped out, and the control will start resuming execution from whatever the address specified by the link register. That will be nothing but the instruction that follows the subroutine call. Fine. So simply we can say that the call instruction is just a special form of branch instruction. What is branch? Branch is the one which transfers control from one place to another place. So call instruction is also one form of branch instruction. Okay. And what the call instruction does? Whenever the call instruction executes, whenever the call instruction executes, two things happens. First, the PC content will be moved to link register. Okay, PC means the next address, the address that follows the call instruction. Okay, so that will be the PC content. That will be the PC content that will be moved to the link register, and also the control, the it will branch to the target address of the specified call. Okay, and the control will be moved to the whatever the address specified in the call instructions. Okay, so these two things happen during call instruction. What happens? First, the content of the PC will be moved into link register. Content of the PC means here the address that follows the call instruction will be moved to the link register, and then the control will be moved to the target address, that is the one specified in the call instruction, right? Similarly, when the return instruction is executed, what happens in the sense, the control will go to the address that is specified in the link register, right? So both call and return instructions are special form of branch instruction, and this is how they work. Call instruction will just push the content of it will store the content of PC into link register. Here PC means what? When call instruction is executed, PC will get updated to the initially it will get updated to the instruction that follows the call instruction. Okay, so it is the instruction that follows the call instruction, right? So that one should be moved to the link register. That one should be moved to the link register. Okay, and PC will be updated with the uh, address that is specified in the call instruction, right? Okay, and whenever there is a return instruction, the control will move to the address specified in the link register. So whatever we have discussed so far, it is explained here through a code and also through a small diagram. So if you see here, this is the calling program, and this is the memory locations of the calling program, and this is the subroutine, and this is the memory locations of each instructions of the subroutine. So so at memory location 200, okay, at address 200, there is the instruction call sub. Okay, when this instruction is getting executed, okay, when this instruction is getting executed, what will be in PC? You know, in PC will always contain the address of the next instruction. So when the current instruction is executing, it will have the next instruction's address. What is that? 204. 204 it will have currently PC. But this instruction is a call instruction, which means that it is going to alter the flow of the program. It means after 200, 204 is not going to execute. Rather, control is going to move to the address 1000, which is the starting address of the subroutine. Okay. So whenever there is a call instruction, what should be done? First, move the content of PC to link register. That is, this 204 will be moved to the link register. Okay, 204 will be moved to the link register. Okay, and then and then whatever the address specified in the call, the address specified in the call is call sub, and the address is 1000. That will be moved to PC. So this 1000 will move to PC. So these two things happen during the execution of call. First, the original content of PC will be moved to link register, and the content of PC will be replaced with the starting address of the subroutine, which is specified in the call instruction. Okay, right? And when the return instruction is executed, what happens? The content of the link register. Now, what's the content of the link register? 204. That will be moved back to PC. Why it is moving back to PC? Because again now the execution should start from this particular instruction 204. Okay. So this is how subroutine call and return works. Fine. Okay. So this is okay as long as there is one as long as there is a subroutine call and a return. There is a single subroutine call and a return. Okay. But there is something called a subroutine nesting. There is something called a subroutine nesting, which means that the program calls a subroutine, and that subroutine may call another subroutine. Okay. Are you getting? There is a main program, and this main program may call a subroutine, and this subroutine may call another subroutine, and that subroutine may call another subroutine. Like that, there can be any number of levels. Okay, in that case, if there is nested subroutine call, then for example, if the main program is calling subroutine 1 and subroutine 1 is calling subroutine 2, in the sense, after finishing executing subroutine 2, control should come to subroutine 1, right? After finishing executing subroutine 2, control should go back to the main program. Okay. So now the return address, normally we push the return address into link register. Normally we push the return address into the link register. Okay. So when there is a first call, from the main program to the subroutine, obviously you will push the address where the control should come back to the main program into the link register, right? But again, subroutine 1 calls the second subroutine, right? So during this call, again what happens? Whatever the location where the control should come back after executing subroutine 2, that will be pushed into link register. Now link register will be overwritten. Now link register will be overwritten and its previous contents will be deleted. Okay, what is the previous content? The previous content is the starting address of the main program to where the control should return, and the new content is the starting address of the subroutine 1 where the control should return. Now it has only the recently stored value, that is the starting address of the subroutine, the I mean the return address of the subroutine to from where the execution should continue. Okay, so in that case, if there is, the point is, if there is a nested subroutine call, then the link register will not work. That is, the job cannot be done with the link register. Okay. So then what should we do? So if you see this return address, or if you observe that the return address, or we the control should return back in what order? It should return back in LIFO order, lost in first out order. Okay, if there are nested function calls, if there are nested subroutine calls, the control should return in this order, lost in first out order. Okay, that is, whichever the subroutine that was called lost. Okay, the main program calls subroutine 1, subroutine calls subroutine 1 call 2, subroutine 2 calls subroutine 3, subroutine 3 calls subroutine 4, like that it can go to any level. Okay, subroutine n should return back to subroutine n minus 1. Subroutine n minus 1 should return back to subroutine n minus 2. Subroutine n minus 2 should return back to subroutine n minus 3, so on and so forth. Finally, subroutine 2 should return to subroutine 1, and subroutine 1 should return to the main program. Okay, so if you see, this order is what order? LIFO order. Okay, okay, whichever the subroutine that calls first, that is the one which is getting returned at last. Okay, because subroutine 1 calls 2, 2 calls 3, 3 calls 4, then from 4 it will return to 3, then 2. Okay, so here the return address is generated in LIFO order. So we can use stack. So stack can be the right tool to keep these particular, what you call this, the whatever the return address which we want to push when you are using nested subroutine call. This the return address can be pushed into a stack based data structure. Okay, fine. So let us see that with an example. So, so here you can see what we are doing, in the sense there is a so this is the calling program and this is a subroutine. Okay, here we want to add some n numbers. Okay, and all these numbers are stored starting from memory location num1 to uh, num1, num2, num3, like that n values are there. Okay. So this n also refers to a memory location which contains the number of values which is to be added. Okay, so first what we are doing is move n comma r1. Say if n is 5, then r1 will have 5. If n is 5, then r1 also will have 5. It means totally we want to add 5 numbers. Okay, then what we are doing, move hash num1 comma r2. This will move the that memory location of num1 to r2. Okay, that is, if num1 refers to the memory location 1000, then r2 will hold the value 1000. Then r2 will hold the value 1000. Okay, then what we are doing, call list add. Call list add. So this is used to add some set of numbers. So the control will come here. Now the control comes here. Clear or not. Clear or not. So r0 will become 0. Clear r0 will become 0. Then add r2 plus r0. What is r2? R2 contains the address starting address of the first number, address where the first number is stored, which we want to add. Okay, so that is what is called r0. Okay, so, sorry, r2 contains the uh, starting address of the first number, say it is 2. Add r2 plus r0. What does it mean? R2, here we are using register indirect addressing. The memory is specified indirectly through the registers. Okay, so R2 is referring to this location 1000 which contains the value 2. So 2 plus R0 is what? R0 is 0. 2 plus 2 is then 0. 2. So that will be stored in R0. The result will be stored in R0. Again R2 will increment. Okay. Let us assume this is a the word size is 32 bits, okay, that is 4 bytes. Then the first location, if it is 1000, then the next, then the starting address of the next location will be 1004, okay, 1004. Then what we are doing, decrement r1. Previously r1 is 5, now it has become 4 because already one addition is done. Branch greater than 0, loop. Is this previous result greater than 0? Yes, then loop. Again add r2 comma r0. Now what is r2? Now r2 is updated to 1004. Okay, this is r2. These addresses are nothing but r2. So the value at 1004, say this value is 4, that will be added with the previous sum, that is 2. So this will become 6. Again decrement r1, this becomes 3. Check whether it is greater than 0, loop. So like that you continue. So finally, after performing all additions, there will be return instruction. When the return instruction executed, what will happen? So the link register will be checked, and the control will go back to the instruction that follows the call, which is move. Okay. So during call, what happens? The address of the instruction that follows call, the move instruction address, that will be pushed into the link register. Okay, that will be pushed into the link register. Say the move instruction address is 4, then 4 will be pushed into the link register. For simplicity, I am saying. Okay. And similarly, in subroutine, whenever you execute the return instruction, the content in the link register will be popped out. 4. Okay, and from that location onwards, the execution will continue. Okay. Finally, the results are available in the variable or not, the register or not, and that we are now storing it to the memory location sum. So move or not comma sum. This will move the content of or not to the memory location specified by sum. Right. So this is how the parameter passing works through registers. Okay. Fine. Let us stop here. Other things will continue in the next class.